Okay, so for this question, it asks you to find the initial speed and the maximum height of the ball with the initial height that you give and the final height that you have here, and then also the angle of the ball. All right, so first off, I'm gonna plug in the number that I gave. So cosine of 45t plus. All right, so as you know, cosine 45 and sine of 45 gives you square root of 2 over 2. So I'm going to plug that in for both cosine 45 and sine 45. And then for this part right here, I'm going to solve for t. So it's going to be root 2 over 2 times t equal. So as you know, it was 300 from the home plate, which is the x direction. So it's going to be this whole I component going to be equal to 300. Then I'm going to solve for t. After I solve for t, I'm going to plug that t into the j component to find the time or the initial velocity. So I'm going to 600 over root 2 v naught equal t. Now I have that. I'm going to plug in the I can also, actually, I'm going to simplify this. It's going to be 300 root 2 over 2 over v naught. Okay, and all of this, I'm going to plug this into the j component. So as you know, initial height and the final height is 3 feet, or 3 feet. So 3 plus v naught root 2 over 2. That's for the sine of 45 right here. And then the time is from the I components. So 300 root 2 over v naught minus 1/2 32 gives you 16. Also the time, I'm going to plug in the time from the I components here. 300 root 2 over v naught square. And then the j component is going to be equal to 3. Going to be equal to 3 since the final height is 3. So the 3 and the 3 here cancels out. Gives you 0 equal v naught. Actually, the v naught also cancel out right here and right here. And then root 2 multiply root 2 equal 2, and the 2 cancel out at the bottom. So you get 300 minus 16, 300 v naught, and then square. And then you can bring this to the other side, the negative to the other side. So you have 16, 300 v naught equal 300. And then now you can solve for the v naught. You can solve it algebraically. The v naught should be equal to 97.98 feet per second. Remember, rounded to 2 decimal places. Alright, so after you got the initial velocity, now you're going to find the maximum height, and then recall back in calculus 1. The maximum height is reached when the derivative of the vertical component is 0. So then you can solve for the time when you set the vertical components equal to 0. Then you have y of t equal to 3, the initial height, plus v naught. Sine of 45 gives you root 2 over 2 times t minus 16 t squared. 16 is from 1/2 32. So now you can plug in the v naught from the previous solution. So then you have y of t equal 3 plus 97.98 root 2 over 2 times t minus 16t squared. Now at this point, you can take the derivative. So y prime of t equal 3 goes away. So now this derivative right here and this, you can use the power rule. So 97.98, oops, root 2 over 2 minus 32t. And now you can set the whole equation equal to 0, and then you can solve for time. And then you should get the time for the maximum height. So then you can solve for t when the equation equal to 0. So you set 0 equal to 97.98 root 2 over 2 minus 32t. Just gonna do it over here. 32t equal to 97.98 root 2 over 2. Alright, now you can solve for the time by dividing 32 both sides, and then you have t equal 97.98 multiply for 32 root 2 over 2. Oops, not multiply, should be dividing. So should be 64. Okay, now you have the time. Now you should be able to plug this back into the original equation. Right here, you should get the maximum height. So if you go y of t equal, now you have the v naught, also the time, you should be able to solve for the y of t. So you have 3, it's the initial height, plus v naught gives you 97.98 root 2 over 2 from the cosine 45s, and then the time is from right here. So you have 97.98 root 2 over 64 minus 16 multiply 97.98 root 2 over 64 square. Should be able to do the arithmetic, plug that into your calculator. You should be able to get the maximum height of 78 feet to this decimal places. All right. I wrote this song for